Okay, so the derivative notation, the prime, that's pretty typical. If your function is g, you'll have g prime, which is the derivative of g. It still stands for whatever you want to stand for, the slope of the tangent. This is the derivative notation that we kind of looked at in the calculator a minute ago. dy dx. You say it, dy, kind of pause, dx. You don't say dy over dx because it's really not a fraction. At this moment, it's notation. So this is a line, dy dx. Okay, and what it means is the same thing this means, the derivative of y with respect to x. Now, you've had the with respect to x business before. It just meant that x is your independent variable. Okay? All right. df dx, same idea. You have the derivative of x when x is the independent variable. Okay? And then this is my personal favorite because you can actually put the function here. Remember how we did in the calculator? We did this, and then we put that. Okay? That says I'm going to take the derivative of 2x plus 4. So you can actually put that in there. You can't really do it here. It's sort of like the function notation. Remember, when you were in algebra, you were strictly x and y. I don't think you did. Well, then you said find y when x is 2. And then you, whatever, did, y equals 2x plus 4, and you did y equals 4, 8. Okay? But later on, you said the f of 2 is 8. And that gives you the ordered pair in one statement. Then here you'd be like, wait, what was that x again? And you have to look back either here or here. Okay, this is the same thing. We're finding the derivative of this, okay, which is nice. So if I want to do the derivative of a particular thing. Okay, now, this guy right here, Leibniz, has a cookie created just for the way for him. I'm getting out of my... Okay. All right. So remind me, I brought some of those for you here, but I want to get through this real quick. But this really is the math guide. That's weird, right? Cookies. It's not actually a butter biscuit is what they call it, but they're okay. They're okay. All right. Now, while you're going to do this, I'm going to get the cookies out here. What are the ways that you will be asked to find the derivative? Now, there's at least 10, so we'll start making a list. Now, we have no. Like in the words. What words? No, not it's a table or a graph or that. So, for example, find f prime. That's one way. So you all got that one. Okay. I might shut this recording off. All right. Now shout them out. Shout one out, Lizzie. The f dx, which then you could do dy dx. Okay. Good one, Maggie. Find the slope of the tangent line. That's going to be the derivative. Okay. Good. Another one. Shout it out. Find the slope of the curve. Okay. What else? Velocity. Good. Velocity is the derivative. Good job. Is that you, Jessica? All right. F prime of x is the derivative. So. Okay. Find the derivative. That's good. Very basic. Yes, good. Is f function differentiable? Well, we have to figure out the derivative to figure that out. That's a good one, Lydia. Well, that would go. That's kind of like here. That's saying this is all the Leibniz, those lovely cookies that you're eating. I got it in here. All right. Don't care. All right, anything else? We didn't get up to 10, did we? Oh, okay, your story. Okay. I think you forgot about rates of change. And when we said instantaneous velocity, we really mean instantaneous. So let's make sure, as opposed to average velocity. How about that? It says velocity, though, you're really talking about the derivative. So, all right, and then you could be talking about maybe the instantaneous rate of change here, too. I did. Yeah. Okay. So, one time at the end of the year, we do this, I always do this, and your list is going to grow, okay? But one time somebody told me on my remember when you have to do those student surveys? Yeah. And you're supposed to do them first semester, but I was like, I do them the day before they're due, kind of. Somebody told me, I wish somebody would have said all this different ways of doing a derivative. I was like, yeah. But anyway. All right. So your list is going to grow. The whole semester, we're going to talk about derivatives. Okay? And then second semester, we're going to talk about something else that is related to derivatives, but it's an antiderivative. So, you get that to look forward to. So you just got to recognize, oh, I got to find the derivative. Okay? So let's talk about a particular function here, x squared minus x. We're going to find f prime, which is also known as the derivative of the curve. Okay, now remember f prime of x, the only way we know how to do that is right here. Or the other one, I'm not going to use the other one because I don't really know where I am. Where I am as far as on the graph. I don't know exactly my points of the graph. Okay, so go ahead and get that going. Sorry, I don't want to tease you. I know I'm saying what you think? There's some nibbling on it.
Oh, Miss Butler, when I submitted my homework, I accidentally did the light blue again, so I didn't know. I didn't realize. Oh, I'm just
yeah. Okay, I'm working on it.
That's how mine was last
All right, you caught up to me. I hope you're past me, but got that? Let's start crossing out here. X, negative x, but I started 5 minutes after y'all. X squared, x squared. All right. I do really feel like I have some crazy caffeine going today, but I really don't. I feel like I'm not sure what that's all about. Okay, I still can't plug in my h equals 0, so what should I do, Lawrence Foley? All right. And what does that leave me with, Abby?
2x plus h minus 1.
Very good. That will eliminate my problem. Now I can plug in h equals 0 and get 2x minus 1. So, just for your information, That's f prime. Okay? All right, now let's look at the graphs. And let's cheat and just look at the graphs on here because it'll be quicker. But we've already kind of talked about this. And look, I'm going to leave that one, the derivative of y1, and my y1 is now x squared minus x. Okay? I'm going to leave that one, and then for number 3, which is the black one, I'm going to put 2x minus 1. Now, which two should be the same? Right. So if they're not, that means we're not right. So we're not wrong. We are wrong. So we could, check our work with our graph. There's your first one, there's your second, there's your third. Mine are super fast. I know your derivatives are not that fast, but okay. All right. Anyway, okay. How do you know what?
I mean, I guess if you don't see a third line appear,
Yeah.
so you're right. But
Well, it went over the top of the same one. Okay, but it went over the top of it, right? And you can see it working right here. So that and then if nothing else appears, then you know it's right. Good question. Yes. Wait, what's all the conversation here?
Oh, I did
You
it.
have an issue?
I don't remember what.
I didn't erase it, did you?
No,
X squared minus x. I'm doing this one right here. And then f prime of x is right there. And that's what you should get. Okay. Now, please note, let's take a look at this graph. I'm going to give me another page and look at it real quick here. All right. Double page here. All right. This graph. Let's talk about this a little bit. Okay. First of all, horizontal tangent right here. Let me get a different pen because you can't hardly see that one. Would be right there. I'm going to move it over so it's where it's supposed to be. Okay. Now, what do you notice about the derivative, which is f prime, which is in black? Okay. Where does that, what's the, from here to, it looks like that red dot, without discussing what it is too heavily, what do you notice about f prime? You sure about that?
wait, which one's that?
The black one. Negative. Okay? And, wait, don't say increasing, because it's all increasing. Okay. So what do you know about from the red dot to the rest of the graph? So f prime is positive. Okay. So there is a correlation between Maggie. If you have a question, ask it out loud instead of asking not semi-quietly to Lizzie. Okay? All right. From here to here is definitely negative. It's below the x-axis. From here to here is definitely positive. Okay. Now, what do you notice about? Let's talk about the blue. F. From infinity to the red dots, or to this piece of the thing. What do you know? What's going on with that? F is doing what? Decreasing. Good job. Okay, and what about from that to the end? Okay, so there is a correlation. It's going to be very important for you to remember that at some point. So that's the first instance you have of it. That's what we're comparing. That's what we're happening. That's what's happening. Okay, let's look at first derivative, second derivatives, and maybe third if we can go there. Yes, we can. I guess. Okay. If f is a differentiable function, what does that mean? There is a derivative. It is continuous, that is implied. Okay, then its derivative f prime is also a function, so f prime may have a derivative also. Okay, so what would you call the derivative of the derivative, do you suppose? That's how you write it, otherwise known as this. It's called the second derivative. The derivative of the derivative is the second derivative. Okay, we still got a function. We could have a third derivative. All right. Now, this notation, I took the derivative of the derivative. This is the derivative. This is the derivative of the derivative. So this is how we write the second derivative. Okay? Now, every test, I have at least one person on the test that says, I'll say, find this, and they'll come up to my desk and I'll say, I don't know what that means. Well, I'm not going to tell them, because that's what you're reading the notation. You're supposed to know what that means. Now, please don't think it's really not written correctly because you didn't get to decide how to write that. Somebody did, yes. Technically, dx should be in parentheses, but it's not really this squared. It's just notation. So be careful, that is the second notation. That is the second derivative. Okay. All right, so f double prime x will be the slope of the curve f prime. So let's say we got this one to look at. Oops, wrong thing. All right, so you have the first derivative, or excuse me, the function is x squared. The derivative is 2x plus 1. X squared minus x was f. F prime was 2x minus 1. Maggie, tell me what f double prime is again.
B squared y.
No, just tell me what it would be specifically right here. You can answer this question last time. What's the second derivative of this whole function? What's the derivative of 2x minus 1, Maggie? Okay, that's the second derivative then. Okay? Anybody give me a third derivative? 0. The derivative of a constant is 0. Okay. All right, so you'll get used to all this if you're like, wait, I'm not quite there yet. You'll get there. Okay, don't worry about that. Okay, let's talk about the most familiar example of a second derivative would be the acceleration. So in other words, if we take the derivative of the velocity, we have the acceleration. Okay? And if you recall, the velocity is the first derivative, so the second derivative would be the acceleration. Okay? And acceleration, if we remember our physics, what does that mean? It's like you're pushing the same direction it's going, it's speeding up and all that kind of, yeah. All right. But anyway, mathematically, to find the acceleration, you take the second derivative. Okay. So we already talked about this. F prime, we said from the last page was 2x minus 1. Look at F double prime, we already said was 2. Okay. We already went there. So. All right. And remember, the derivative, the second derivative is the derivative of the derivative. So you're just saying, well, what's the slope? This is a line. That's the only one that you do quick like that. Right now, anyway. Okay? All right. Yes?
On your test in the corner, I'm looking for people who are doing this. Put x squared minus 1.
Oh, thank you, thank you, thank you.
Yeah.
Let's try that again. Thank you. All right. Thank you, thank you. Okay. All right. Any other comments, questions, things I need to change? Okay. All right. Now, this is, both of these are, there's one that's F, there's one that's F1, F prime, and there's one that's F prime. Your job is to figure out which is which. We're going to do this, the first one together, And then we're going to try to find the second one on your own. Okay. Now, there are three functions, okay? And sometimes, like, you're just going to say, okay, let's say this is this one right here. I'm just going to take a wild guess and say that's F, okay? Now, I'm not saying it is, I'm just guessing because sometimes that's where you have to start, okay? So now we have to look at increasing, I'm going to highlight that, and decreasing, okay? F, decreasing, F, increasing. Okay, did I lose anybody yet? All right, now, we just said on the other page that the F prime should be what when F is decreasing? Negative. Do not confuse decreasing and negative as in the same thing. They're not. Now, what F is decreasing, F prime is negative. If F is increasing, F prime should be positive. I believe there is one that fits that criteria, right? Which one? The line. Okay, so then that has to be F prime. Except, wait, we have one hanging out here. Okay, now let's look. What do you know about F prime as far as increasing and decreasing? This right here, what do you know about it? It's always increasing. Good job. Always increasing. So that means what? That its F double prime should be always what? Wait. The relationship between F and F prime is the same as between F prime and F double prime. So it should be positive. Is this dash thing all positive? Yes, no, maybe. That is positive. This is definitely not positive because it's all underneath this axis. So, back up the train here. This must be F prime. This is F double prime. Okay? That leaves this for F. Okay, so we're going to start over to check. Why is your hand raised?
Do we have to like find the negative and decreasing parts to do this? Or can we just say, like the one that goes like that would be like the estimate?
Okay, but they're not all power functions. That will work for power functions, but it won't work all the time. Okay, but yes, if that works, it works. Okay, so let's see. I purposely guessed wrong so that you knew what to do when you. Okay, so this is F. Okay, tell me what you know about F now. Is it increasing and decreasing that part? So this is increasing till about right here, or then it's decreased. It's still increasing, right? So this F is always increasing. So F prime has to be always positive. Which one are we talking about then? Which one are we talking about then? I don't want any questions right now. The prevalence. Okay. So this is F. This is F prime. We already checked that this line is the derivative of this, right? Okay, so we're good. So just to be clear, the dashed one is which one? F. Which one's F prime? Okay, I think they called that. And so it's okay, as long as you can. Okay, and then F double prime was the line. Okay, now what's your question, Abby?
When you say always positive, are you saying always positive slope or always?
No, always positive. That's it. And then always right here. No, positive slope is not the same as positive. Good distinction. All right, ladies, I'm going to have you try this one by yourself. See how good you do. Just FYI, just to This is not a power function, so you're a little, that was good. All right. Moving up the triplet lines. How do you do that? There are many in here. Times those 9, so there's about half each if everybody wants one. And it may contain almonds, hazelnuts, and peanuts. You're out. Would you like a half of one? Breakfast? It's like the butter biscuit is like on the bottom and then it's chocolate.
You don't like them.
You're gonna look. Oh, I thought you were asking me to get the question.
Okay. You didn't get that.
No, I'll tell you why I'm right. You're
Sorry.
You know, it's only maybe you know that.
I'm sorry.
Not too different.
Why does that make you in a bad mood?
Like, dang, I don't like what happened.
Oh, that's right. Sorry, conceal this bed. Right, anybody done? Not. All right. Let's let f of x be, oh, bless you, 2x squared. Let's find f prime and then find f double prime. Okay? So first we're going to find f prime. How are we going to do that? Only one way we know how to do it, not graphing it. We don't want to graph yet. Use the equation. Which equation would that be? Okay. 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 All right, let's start plugging in. Are you going to do it yourself? All right, let's do it ourselves, and let's go ahead. When you got that one, check with recording. All right, and then I know most of you got this because we already talked about that. So we get 4x plus h, 4h minus 4x, the 4x cancel. H is canceled. And we get 4. Okay? So, f was 2x squared. F prime was 4x. F double prime is 4. Okay. Why so much conversation here? You two? Yeah. Yes, yes. But I just wanted to show you in case you weren't there yet. When we start chapter 3, 3.1 and 3.2, you're going to find, are you kidding me, the shortcut, like you know a shortcut already. You know the derivative of that because you're doing a slope thing. Okay, now, I want to know what f prime at 2 is. Now, it's not 0, f prime 2. Okay, and please don't say it out loud because then that takes the thoughts out of somebody else's head. Okay, f prime 2. Please tell me you're not going to start over with limit x approaches 2 of f of x minus f of 2 over x minus 2. You could, but that's just not efficient. What are we going to do instead, Sophia? Plug what in? Yes. You're going to take this, and you're going to say if f prime of x is 4x, Then f prime of 2 just says plug 2 in for that x, and that is 8. Okay? Good job, Sophia. All right, tell me what f double prime of 2 is. You're asking me, I asked you first. Yeah. There's nowhere to put the x, so every single value of f double prime is going to be 4. Okay, let's get our calculators out. And let's put in, for y1, let's put in, I'm going to clear everything out. Clear it all out. Okay, I'm going to put in 2x squared. Okay? All right, now, I'm not going to put the derivative in, but I'm going to find, what's an application, a graphical application of f prime. We know f prime of 2, I guess I'm not doing that anyway. I was going to do a tangent line.